Hi, and welcome to my tech talk about Connectivity Engine, the technical part of the platform, or the technical discussion of the platform. So, who am I? My name is Pontus Ullgren. I work at Red Pill Impro in Karlstad. I'm the principal architect behind Connectivity Engine and the concept of Connectivity Engine. So, Connectivity Engine, what is it? It is a managed integration as a service that we offer to our customer. But it's more than just an integration platform. It's a set of best practices and a methodology of working as well. So we have a process of developing and delivering the API and integration to our customer. It begins with the requirements gathering that our customer does within its own organization to identify APIs and integration needs and the requirements that those API and integration has. They then feed that into our team in the plan and design phase. In the plan and design phase, our team goes through and validates the requirements for the specifications and looks through what business information or what business objects are being transferred within this integration. We also look at what type of security does this integration or API require? What information classification does the customer have on this information? We look at the consuming and producing systems capabilities. So we look at how can we communicate with the systems involved in this integration? And we're not just looking at the technical contract here, but we're looking also on the SLA that these systems can provide. For instance, if we have a requirement that we need to process X amount of messages per second, we need to make sure that the system that gets these messages also can process the same amount of messages. Otherwise, we need to do something about that in the design. We look at the data format. Is it XML, JSON, something else? We look at the message size and the volume, as I said, of those messages. And we compile, and we also look at if there is any requirements for data transformation. Do we need to change the format? Do we need to enrich data from a third system or something like that? The outcome of this phase is that we get one or more integration contracts with the systems that we interact with. These contracts define the SLA that we require from those systems to be able to handle or to be able to meet the requirements that our customer gives us. The second thing that comes out of this phase is that we also have a design and a high-level design of the integration. How should we do this integration? And we also have a specification of the different APIs that we interact with in this integration. When it comes to the design, we tend to try to build our integration in an API-first approach, which means that we are building the different parts of the integration at different APIs at different layers. So, for instance, we have a system that needs to consume data from these backend systems. So in this case, we have a web application that the customer is developing. That web application needs to get access to customer information, which is stored in Salesforce and Loqua. It also needs to get data from the order system, which is a custom-built in-house order system. What we do is we build these backend APIs, which exposes the data from the different system as a canonical data model for the customer data and for the order data. This information is then reused in the service layer where we implement a business process. So in this case, we have the business process of getting the status of a certain order or getting the order history for a certain customer. Those communicate with these backend systems. And on top of that, we build the front API, which is the API that exposes the data in a unified manner towards the consuming system. In our case, the web frontend. The benefit of building in this way is that when we add a second, we have new requirements. We have a second client coming in that needs to communicate with, get the same data. We can build a new front-end API. So it's the same data that we're going to expose, but this new client has some different requirements. For instance, they want to authenticate in a different way. They want to have the data formatted, transformed in another way, or something like that. We can then build this API, and that API can then reuse the service layer to get the data that it wants and present that to that client in the way that it requires us to present it. We can then also add, so the mobile app should always also be able to process or show shipment status from one of our logistic partners. So in this state, we can build a service layer where we can get the shipment status. That service layer can then talk to different APIs depending on the shipment ID to be able to ask the different the logistic provider that handles that shipment and provide that upwards in a canonical format that can then be displayed the same way, regardless if it's PostNord or UPS that handles the shipment. So the next phase, once we've done this high-level design, is the build and integrate phase. Since it's a managed integration as a service offering, we take care of the development of the integration or API as well. This is handled by an internal DevOps team, so where we have developers and operations, all of them from Red Pill Impro, working together to build the integration for you. We work test-driven, which means that we define functional test, integration test, performance test, and acceptance test upfront as part of the design. And we then implement these and make sure that every time we develop or every time we release something for development, that these tests are being that these tests pass before we go on to doing before we go on to do the release of the integration. This makes sure that any bug fixing and things like that does not re-implement, or we don't get any regression bugs, or we know that we meet the requirements that are put up by the client. We're working with continuous build and deployment into the test environment. So every time a developer does a change, push that into the code repo, that is being picked out by our continuous integration, continuous delivery mechanism, and then being built, tested, and pushed into the test environment where we can run other tests as well. We do have automated deployments into production. These deployments into production are manually triggered, so there's a person going in and actually trigger the deployments into production, but they are automated, making sure that we don't do mistakes during the deployment and that each deployment is done in a specific manner every time. So the outcome of this phase, the build and integrate phase, is that we have a deliverable that can be deployed into production. We then come to the operate and manage phase. So again, this is a managed integration. It's a full SaaS commitment. We take care of the development. We take care of actually doing application maintenance and management and operation of your integration. Again, this is done by the same DevOps team that did the development. So it's the same team. We don't do a handover to a separate team that does the maintenance. We have the same team working with you all the way from building your integration, implementing it, and to operating it. We make sure to handle both infrastructure and code and configuration as code. That means that all our definitions on how to set up your integration, how to run your integration, is handled in files that are stored in a version controlled way, in version control system. And that way we can see what changes has been done when, who did the changes, and using a automated deployment routine, as I discussed earlier, we take that infrastructure infrastructure definition and code and use those when we do the deployment. That makes it easy for us to know that if we redeploy your application, if you want to roll back, the actual versioned configuration that we are using for this instance is being reused or is being used every time. So we can do repeatable and predictable deployments. We're also transparent when it comes to communication with our customer. So if we have a problem, if there is something wrong in our platform, if it's something wrong in the implementation, a bug, if there is something wrong with our communication towards a backend system, we track that, we report that back to the customer, and we also do a root cause analysis and tell the customer this was what was wrong, and this is what we're doing to make sure that this error does not repeat again. If we can do something about it, of course. And if we can't, we tell you that as well. This is a problem that we can't fix. We need help from a backend system or something like that. And then the last phase, share, engage, and improve. So this phase is about that we are using what we call an active application management, where we proactively suggest changes to you as a customer. We do this by using metrics. We're using this by doing logs to observe how the API and integration works for you. And we see, for instance, if the amount of traffic, your business is successful, so the amount of traffic for a certain API is increasing with the sales you're doing. We can detect that, and we can then go to you and talk to you and suggest that we should up this implementation. We should up this to have a HA redundancy. We should span out. We should scale horizontally for this API, so to make sure to meet the demands that we're seeing that you are having. If we find other issues or if we find other improvements during the operations, we also collect them and we report them back to you. And you can take the decision if you want to implement or not. We use a wiki-style documentation and make sure that those documentation is stored together with the code. That ensures that when we do changes, we make sure to also update the code, so we don't get code or requirement documentation or things like that are being stale and not follow the development of the code or how that develops over time. So these are the stages that we are, or the process that we're using to develop APIs and integration for you. So the actual technical stack. So what we provide in our technical stack is an API manager and gateway where we help you expose your API, make them discoverable for the consumers. We also apply, of course, the gateway will apply any security policies and any security features that we require for consumers to be able to communicate with your APIs. We also have then a connectivity layer, which is where we actually implement your APIs and integration, where we do the legacy modernization in case you have a legacy system that you want to expose as an API, for instance. As I said before, we're doing an API-first approach to this, and that means that we have many different containers, so it's kind of microservices architecture. It's not really a microservices in the full sense, but you could compare it to that. And for that, we need some way orchestrating this to make sure that the number of instances of a certain API implementation or a certain integration is running the number of instances that we want it to run at every time. For that, we're using a container orchestration tool to make sure that these integrations are running and so on. And this is also where we have this infrastructure as a code. So the definitions, how many instances are running, how big should those instances be, everything like that is stored as code and pushed, and when we deploy, we push that configuration into the container orchestrator, and that then makes sure to fulfill those requirements. We then have an observability layer where we can trace, where we can, of course, collect all the metrics that I talked about, how many calls, how long does each call take, and so on. We also store logs, so we can go back and troubleshoot and have traceability that way. And we also have distributed tracing, where we can actually follow a call through the whole chain from the API manager into the integration or API implementation and down to the backend system, and see when did it go wrong, how much time did each step take, and so on. What we don't provide out of the box is identity and access management. This is something that we can integrate with. So if you have a EM IDP solution, we can integrate with that solution that you in your organization have. If you don't have it, we can discuss and talk with you and sell that as a separate service as well, but that's another. So in this offering, we do not include AM, but we can integrate towards EAM solutions of your choice. So this is actually kind of the level that we feel that you need to know about this stack, because we take care of the technical nitty-gritty details. But of course, as I said, we're open, we're transparent. So if you want to look under the hood, we're more than willing to show you under the hood as well. And as I said, this is a technical presentation, so I will show you under the hood. So everything in the stack is open source components. When it comes to open source, it's very important for you to pick an open source project that is sustainable, that you know you can rely on. There are a lot of open source, a lot of good open source, but there is also a lot of, I don't want to say bad open source, but there is a lot of open source out there built and perhaps not governed, doesn't have a governance model around it. So when it comes to selecting components, we have some criteria. First of all, we want the project or the open source component that we select to actually solve the problem that we have, the problem and requirements that we have. Of course, we don't select a tool that doesn't fulfill our requirements. We also want the project to be licensed under an OSI approved license, making sure that it's licensed under a license that we all know what it means. We also try to avoid projects that are backed by companies that use an open core model. The reason for that is that we see a tendency for those projects. I'm not saying every project that has an open core model does this, but we often see a tendency where you start with an open core model, it's still very open, and you see it sliding towards the more proprietary end of the spectrum. So we try to avoid them. It's not always the case. Sometimes we see a project that is so good and fulfills our requirements to such a level that we anyway wager to include it in our stack. We make sure that the projects that we select have an active community. And that's both that we see that they do regular Git commits, they do regular releases, they have a release cadence, they have a governance model, but also that there is an active forum and that they are open for external contributions as well, that we can go in and get help, but also help the project develop. So we're looking for a bazaar and not a cathedral. Just because a project is open source doesn't automatically make it a bazaar. Many open source projects are still only developed by a tight community that doesn't allow or doesn't want to have external help. But we try to find the projects that are open to contributions, just because we want to have an interaction with the project in our when we work with it. As I said, we want them to have a proven release cadence and a commitment to security, making sure that there are community. It's a community that regularly releases patches and security fixes in binary format. We also want the project communities to show that they are still innovating. that they don't go stale, that they don't sit down and are content with the product that they have, that they see that our world is changing and they need to change with it. And then the components we select are always under each consideration. So if you as a customer has a suggestion, why don't you look at this open source project and why don't you incorporate that into your technical stack? It would be a good fit. Then we always open to that as well. We would take it, we would discuss with you, we would investigate and evaluate that project, and we would come back to you and say, yes, it's a great fit, or no, we don't think it's a fit right now because this and that. But we're always open, we're always considering changing the components or evolving our platform with new or different components. And we have a idea on how to do that in a sustainable way without losing maintenance or that we can still maintain the older versions of our integrations as well. So what have we selected then? Well, for the API Manager and Gateway, we have selected VSO2 API Manager. And the reason for that is that it is, as far as our consideration, is the best open source API manager that has the full life cycle of the how to handle an API. There are a lot of API gateway platform out there, but this is the one that we see right now has the support for the full life cycle. For the connectivity layer, we're using Camel, which is an Apache project for providing components for integration needs with different systems. It has more than, I think, about 250 components for integrating with different systems. We're also using a Spring Boot as the application framework for that. It's a proven, Spring is proven platform and a very active community. So yeah. For messaging, we're using Apache ActiveMQ Artemis, which is again a proven project which has been along for a long time. They are evolving. They are showing that they are going with the times. It's governed by the, as with the Camel project, it's governed by the Apache Foundation, which makes it a very independent. It's independent from other vendors as much as it can be. For the container orchestration, we're using OKD, which is a Kubernetes distribution. It's sponsored by Red Hat, but it's an open source solution which has shown commitment to the community and is, I would say, since it's Kubernetes, it's very much kind of the de facto standard when it comes to container orchestration these days. For the observability layer, we're using Elasticsearch to store metrics and logs. We're using Kibana as an analytics tool towards these metrics and logs. And we're using Jaeger as a solution for distributed tracing to get tracing, to help us with tracing and troubleshooting. It also has an implementation of Open Tracing API, which is very good for us when it comes to openness. As I said, we do not provide the EM solution out of the box, but we have worked with ourselves implementing Keycloak and VSO2 identity providers at customers, so we can help you with that as well if you don't have a solution on, in-house already. So on the development side, so that's the runtime or the kind of deployment view, the deployment technical stack. So on the development side, we're using GitLab, which is an open source alternative to GitHub that we host ourselves. So it's hosted on our own servers within our own data centers, so you can rely that your code is safe and doesn't being shared with some American conglomerate that would share it with everybody else. We're also within, so our data center is in Norway, so we're within kind of the extended EU zone, so to speak, which makes us, and since we're not an American company, we're not under the Cloud Act as well. So from a legal point of view, that's good. So we use that for source control, project management, and issue tracking. We use Jenkins as the continuous build and deployment engine. We use SonarQube to automatically help us get reporting on our code quality. We use Maven for build dependency and so on. And again, we changes. If you have some certain requirements, we always take those into consideration, and we're open to changing these components, as I said as well. But again, for you non-technical people, I would say this is the view that you need to look at or have in mind. We provide you with these functionalities. The actual nitty-gritty details, you're welcome to look at them. We're happy to talk about them for hours and hours and hours and hours. But if you don't want to, this is what you your takeaway. So when it comes to scalability, high availability and recovery, we always take that into consideration when doing the design and develop. So that's part of the design plan phase. We're taking the consideration, what are your requirements around these areas, and we take that into consideration. One way of doing that is that we make sure to differentiate workloads. So for instance, if an integration is part a synchronous API where you have synchronous calls in, but you also have a scheduled worker where you do batch work. We don't put them into the same binary or the same artifact. We separate those so that the synchronous work can be scaled separately, but the batch work should perhaps only be run in a single instance because we don't want competing consumers there. So that way we separate different type of workloads in different processes, making sure that they can scale differently depending on the needs. We're using OpenShift Kubernetes to schedule a workload. So even if you don't have a full HA, you have multiple instances of your application, the OpenShift, the nature of Kubernetes will make sure that if one worker node in the cluster fails, it will automatically spin up that work on another node. And of course, if you have multiple instances of your workload, then of course the load balancer will make sure that no traffic or as little traffic as possible is lost. We try to build everything as stateless as possible. Where it's not possible, we use the message broker to store the state. So we have a central place where we store the state. So if there is something we need to take care of to resend or something like that, we store that in the message broker to have a place where we can transactionally make sure that the state is stored safely. We have also the possibility to deliver 24/7 with a 99.9% SLA, if that is a requirement. When it comes to security, again, this is an integrated part of how we think. It's an integrated part of the architecture and how we build and design our integration. We have different tenants within Kubernetes, the OKD, so making sure that different customers cannot access each other's integrations or each other's data. We default to using TLS for all communications, both externally but also inside the cluster as well, making sure that your data is always encrypted when it's passed through the wires. We also have support for the most commonly used security protocols, such as SOAP via security for SOAP services, or for REST services, Auth2 JVT tokens, or HMAC SHA-256 for encryption. So that's all for me today. Thank you for listening, and hope you enjoyed this Tech Talk. Thank you.